Okay, 2012 AMC. This is problem 21 from the AMC12A, and to be honest, this is the one problem that I just couldn't get. I got stuck. I looked at the forums on Art of Problem Solving and saw the one thing that I missed. And so let's get down to it. I actually looked at someone else's solution to come up with my solution. I'll show you where that happened. Let a, b, and c be positive integers with a greater than or equal to b greater than or equal to c, such that a squared minus b squared minus c squared plus ab is 2011, and a squared plus 3b squared plus 3c squared minus 3ab minus 2ac minus 2bc is negative 1997. What is a? And we have these choices, and what a problem. So, what I did notice, and what we should notice pretty much right off the bat, is if I look at these, so this doesn't look nice to begin with. However, I have a squared plus 3b squared plus 3c squared minus 3ab minus 2ac minus 2bc. And I have a squared minus b squared minus c squared plus ab. If I add these two, which I'm going to do right now, which I did notice, you will get to 2a squared plus 2b squared plus 2c squared minus 2ab minus 2ac minus 2bc equals 14. I saw that. And then I started going in loops. Here's what I missed. This all factors. Let me write it out for you. I can have this as a squared minus 2ab plus b squared plus a squared minus 2ac plus c squared plus b squared minus 2bc plus c squared equals 14. I missed this. I can't believe I did. And each of these are perfect squares. This is going to be a minus b squared plus a minus c squared plus b minus c squared equals 14. So I have, now these, a, b, and c are all integers. So these, a minus b, a minus c, and b minus c must all be positive integers. And the only way to get perfect squares of integers, or perfect squares, to add up to 14 is, let me write this over here because I'm not going to try to make any claim yet. But if I had 1 squared plus 2 squared plus 3 squared. That's the only way I can get perfect squares to add up to 14. Next thing, I know A is the biggest, I know C is the smallest. So right off the bat, I know that A minus C has to be 3. Okay, A minus C equals 3. And I can use this in the first equation to substitute in some stuff. So I actually rewrote this as, this implies that C is equal to A minus 3, and then do some substitution to see that A squared minus B squared, put in the A minus 3 minus A minus 3 squared plus AB equals 2011. And then the A minus 3 squared, well, I'm just going to do it, I'm running out of room. So A squared minus 6A plus 9, but I subtract it all off. So A squared minus A squared cancel. I will still have this negative B squared. I will have negative minus 6A, so I'll have plus 6A. And I will have a minus a positive 9. Minus 9 plus AB is equal to 2011. From here, I'm going to move the 9 to the right-hand side, so that'll be 2020, an even number, which is important. And what's left over here, I will have 6a. And let's combine this in factors. So I'm going to have this as plus b multiplied by a minus b. So I did some factoring there. I know I skipped it around a little bit. And what I notice here is that this must be even. It must work out nicely. I'm not sure, and we haven't gone back to this, I'm not sure whether a minus b is 1 or a minus b is 2. So I don't know which one. I'm going to actually show you both. So a minus b equals 1 or a minus b equals 2. It's one or the other. We don't know which one. Why'd I put a question mark there? Okay. So let's just first check to see what happens if a minus b is 1 and see what we get out of here. So assuming a minus b equals 1, we'll get, so that's the same thing as saying a minus 1 is equal to b. Substitute those in, I'll get 6a plus a minus 1 times 1 is equal to 20. I'm going to solve this through. I will end up with 7a equals 2021, but 7 does not divide 2021 evenly, and I need integers, so I know that a minus b cannot equal 1. So now let's look and see this. It better work out for us, so let's check and see what happens if a minus b is 2. And it has to be at this point. And that means that a minus 2 is b. And I'm going to substitute those in, so I get 6a plus a minus 2, a minus b is also times 2, equals 2020. I go through and I multiply, combine like terms, get it over there. I have 7a is equal to 2024. Divide by 7, and a miraculously has to equal 253. Answer is E.